So this VPN protocol has 99% less code than OpenVPN, and that single fact changes security, performance, and trust. So let's talk numbers. OpenVPN runs on tens of thousands of lines code, basically a library-sized volume. IPsec, on the other end, implementations are hundreds of thousands of lines. Maybe look like this. WireGuard, just 4,000 lines, basically a notebook. 4,000. That's not an optimization. That's a design philosophy. So in security, every extra line of code is something you have to trust, maintain, and defend. So what happens when you remove 99% of it? That's what this video is about. Okay, so what does that actually means for you? And WireGuard is a modern open source VPN protocol designed from the ground up to be simple, lightweight, fast, and using state-of-the-art encryption. And before we go any further, let me set expectations. This is not a technical video. I'm not going to walk you through installation and commands or step-by-step setups. There are already many great technical guides online that do exactly that. This video is about understanding WireGuard simply and clearly in under 10 minutes. So here is the agenda for this video. First, why WireGuard is fundamentally different from OpenVPN and IPsec. Then how its design makes it faster, simpler, and more stable. And we will break down the cryptography at a high level, no math. So don't be worried. And finally, who is actually using WireGuard today in real-world VPN services? So if you understand these parts, you will understand why WireGuard matters, even if you never touch a terminal. So what WireGuard provides? So you get more stable connection, meaning less chance of dropped session, up to 4x faster real-world throughput compared to older protocols, modern cryptographic like ChaCha20, Poly 1305, and Curve 25519, I swear I'm not inventing this, without any legacy baggage. So this is not an hype. It's a math and design philosophy baked into the protocol. So why WireGuard is so good? And you can think of the big, heavy OpenVPN and IPsec code bases like a giant instruction manual for a machine with thousands of options. It can do a lot, but all that complexity costs performance, speed, and sometimes also security. And WireGuard flips that on its head. It's lean, it's modern, and purpose-built. Less code means faster packet handling, lower CPU overhead, and fewer opportunities for vulnerabilities. And because it's integrated directly into the Linux kernel, it runs extremely efficiently on servers and devices. Yes, you can run it also on the mobile. And yes, WireGuard uses modern cryptography, and this is one of the biggest reasons it performs so well. Unlike older VPN protocols, WireGuard doesn't negotiate dozens of cipher suites, fallback options, or legacy algorithm. There is no long handshake, no downgrade risks, and no guessing which encryption you ended up with. Instead, WireGuard is opinionated. It uses a small, fixed set of best-in-class cryptograph primitives. So the first one, in example, ChaCha20 for encryption. And this is high-end modern stream cipher designed to be fast even on mobile devices and systems without hardware acceleration. In many real-world scenarios, it actually outperforms AES, especially on phones and laptops. Poly 1305 for authentication, and this ensures message integrity. In simple terms, it guarantees that data hasn't been tampered within transit, and it does so extremely efficiently. Curve 25519 for key exchange, and this is a modern elliptic curve algorithm designed to be both fast and resistant to known cryptographic attacks, while avoiding many of the implementation pitfalls of older curves. The key idea here is this: WireGuard doesn't try to support everything. It supports only what's considered secured today. This is not a limitation, it's a security advantage. Now, here is where this stops being a theory and becomes very practical. And today, many major commercial VPN providers, yes, either use WireGuard directly or build on top of it. In example, a NordVPN created a NordLineX, which is essentially WireGuard with an additional private layer. WireGuard itself is very fast, but it uses static keys by design. So NordLineX adds a double NAT system, so users do not get persistent internal IP, solving a privacy concern while keeping WireGuard's performance. Another example is PIA, or Private Internet Access, and this offers WireGuard as a high-speed protocol option across the application, especially popular with users who want maximum throughput and lower latency. Another example is CyberGhost, Mullvad, and others, and they have adopted WireGuard as a first-class protocol, often making it a default choice for new connections. What all of these services are doing is the same thing. They take WireGuard's raw speed and simplicity and wrap it with dynamic IP handling, key rotation, privacy safeguards, and polished applications that make it usable for anyone, not just engineers. So whatever you are, a power user or not, you're already benefiting from WireGuard, often without even realizing it. So I think you got it. If you want a faster VPN speeds, better performance on mobile and desktop, a leaner modern protocol that's easier to audit, and a strong modern cryptography, then WireGuard is where things are heading. And no, you don't need to install servers yourself to take advantage of it. Most major VPNs already include it, often as the default choice. So if you found this video useful and want clear, no-nonsense explanations about cybersecurity, networking, and how modern systems really work, you can find me on YouTube and join the community on Telegram. The links are on the screen now and in the description of the video. So if you think this video can help someone else understand VPN better, share it and help spread the knowledge. So please, if you are still not a subscriber, you like the video, please subscribe. It will take you only a second. Like, share, and leave your comments. It helps me a ton, and see you in the next video.